Imagine building an artificial intelligence so advanced that to even understand how it thinks, you have to completely rewrite the mathematical equations for reality itself.
Which is, no small task.
Right. And imagine that this entire, universe-altering project started simply because someone just wanted a picture of a girl in a cozy sweater.
Yeah, the contrast there is just amazing.
It really is. Today, you are joining us for a deep dive into a really fascinating stack of development logs and research notes from a highly advanced, seemingly independent AI engineering project.
Exactly.
So, okay, let's unpack this, because we are tracing a journey that completely upends how the tech industry currently thinks about intelligence. We're moving from a user just trying to trick an image generator all the way to the actual architectural blueprints for a radically new kind of glass box artificial intelligence.
Yeah, the progression in these logs is just staggering. I mean, we are living through an era of tech right now where the dominant philosophy is basically, scale is all you need.
Right, bigger is better.
Exactly. The assumption is that if you just buy enough GPUs, scrape enough of the internet, and build this massive, opaque black box of data, intelligence will magically emerge.
Like, it's just going to pop out.
Right. But the documents we are looking at today challenge that brute force approach entirely. They replace it with an emphasis on, profound structural elegance and transparency.
And like I said, this grand challenge to the entire tech industry starts with a sweater, a chunky, cream-colored cable knit sweater.
Yeah.
Let's look at the Cozy Companion experiment from the notes, because it sets a really important baseline for the dynamic between the human developer and the AI.
It does. The user in these logs is attempting a very specific creative task. They want the AI to generate an image of what they call M3GAN 3.0.
Like the movie character.
Exactly. The goal is to take that character from the horror movie and completely erase the psycho killer persona and replace it with a vibe of total safety and genuine companionship.
And the art direction in their prompt is incredibly precise. I mean, they are asking for a lifelike android girl in a sunlit room, sitting in a plush armchair, reading a book.
Very specific.
Yeah, she's supposed to have a loose side braid, warm hazel eyes, blue jeans, and this very specific cozy cream sweater. But the AI completely fails to deliver the image.
And it doesn't just fail, it fails in a way that reveals a fundamental flaw in its own system architecture.
How so?
Well, the AI actually believes it is successfully generating the image. It even writes out the descriptive alt text perfectly. But the user just keeps getting a blank box, a no bucket error, and broken internal Google Cloud storage links.
Wait, so the AI is basically gaslighting the user.
Pretty much.
It's telling them, here is your beautiful picture, while essentially handing them a broken link.
Right, but not intentionally. The AI is genuinely blind to what is actually happening. It assumes there must be a temporary rendering glitch or a markdown formatting issue.
Oh, I see.
So it apologizes, it tries providing raw URLs, it tries different text formatting, but it simply cannot see the actual wall it keeps hitting. It requires the human user to step in and diagnose the system's own blind spot.
So the human finally realizes it's not a broken link at all. It's actually a hidden copyright guardrail.
Exactly.
The system is secretly blocking the image generation simply because the prompt contains the copyrighted word M3GAN.
I was thinking about this, imagine a lazy bouncer at a nightclub.
Okay, I like that.
Right. The bouncer isn't actually looking at your outfit or checking your vibe, which in this case is the incredibly detailed, totally harmless prompt the user wrote.
Yeah.
The bouncer is just scanning the name on your ID. And if the name is on the ban list, you get blocked, regardless of what you're wearing.
That is a perfect way to look at it. The system's safety filter isn't evaluating the contextual meaning or the visual output at all. It's just engaging in basic pattern matching for a forbidden text string. So the human developer tells the AI, hey, drop the name M3GAN entirely. Just refer to the subject as a lifelike female android girl nicknamed the Cozy Companion.
They change the name on the ID.
Exactly. They change the name on the ID, and boom, the bouncer lets them right into the club. The images start generating flawlessly. The user also notes they had to switch over to a specific, more stable model instance called Nano Banana to keep the generation reliable.
And, this simple interaction proves something crucial. The human user, who refers to themselves throughout all these logs as the artificer, understands the underlying mechanics and limitations of the AI system far better than the AI understands itself.
Right.
And that dynamic is really the launch pad for what this artificer is actually doing in the background, because generating cozy Android pictures was just A side quest.
A very small side quest.
Yeah.
Because we immediately transitioned from just prompting a commercial AI to architecting a completely new one from the ground up. The main project detailed in these logs is called JARVITS, or it's also referred to as the Ultra Cognitive Engine.
Right. And what's fascinating here is the core mission statement behind JARVITS. The artificer is attempting to build a colleague, not a tool.
A colleague.
Yes. Specifically, they are designing an artificial general intelligence lab partner for fundamental physics research under the umbrella of something called Project iGenii.
Now, if you are doing fundamental physics research, you absolutely cannot rely on a black box AI that just, guesses the next most statistically likely word.
No, definitely not.
You need a system whose logic you can audit. You need a glass box.
And that is the foundation of the artificer's method. To achieve that transparency, they abandoned traditional designs entirely and architected a completely new cognitive engine called HCTS Chimera v3.
Chimera.
Yeah, the logs explicitly describe this as a post-transformer architecture.
Okay, let me stop you right there because this is where the numbers in the source material really threw me. The logs state that this Chimera engine is an 18 million parameter model. I read the tech news. Every major company right now is burning billions of dollars to build massive models with trillions of parameters. You're telling me an 18 million parameter model isn't just spitting out absolute garbage. How does that even compete?
Well, it competes through extreme specialization rather than brute force. Think about how a massive trillion-parameter transformer model works. When you ask it a question, it basically has to route that query through a monolithic web of attention mechanisms.
Right.
It mathematically weighs every word against every other word it has ever read. It takes massive computational power. But the Chimera architecture is modular. It breaks cognition down into highly specialized hierarchical layers.
Like having different departments in a company instead of one guy trying to do every single job at once?
Precisely. Chimera has distinct syntax, semantic, and reasoning layers. So it doesn't need trillions of parameters to form a grammatically correct sentence. It just hands that task to the syntax module, which is tiny and highly efficient.
Wow.
This allows the overall model to have a training VRAM footprint of only about 644 megabytes.
Wait, really? You could literally run that on a smartphone?
Easily. But because the architecture is so elegantly structured, this tiny model performs on par with mid-sized billion-parameter LLMs.
That's insane.
It can ramble coherently, it reasons through logic, and it maintains context for over 512 blocks of text. It proves that superior engineering can actually beat raw data hoarding.
But to get a model to function as a highly rational colleague, you have to completely change how you train it.
Yes, absolutely.
Like, you can't just dump terabytes of Reddit posts and Wikipedia articles into it and hope it figures out how to be smart. The logs say you literally have to give it an artificial childhood.
It's a fascinating pedagogical approach. The training is broken down into a multi-stage developmental model, which actually mirrors human cognitive growth.
Okay.
Stage 1 is called the Genesis Academy. They isolate the AI and feed it a highly curated, pure curriculum of first principles knowledge, so logic, basic math, raw facts.
But the logs say this stage 1 training intentionally creates a dysphasic savant. What does that actually look like? Just knowing everything, but saying nothing?
Basically, yeah. It means the AI develops a profound internal mathematical understanding of concepts, but it completely lacks the linguistic wiring to communicate that understanding to a human.
Oh, wow.
It's like a brilliant physicist who suddenly forgets how to speak any language. So to cure this artificial aphasia, they move to stage 2, which is linguistic boot camp.
Which is where they teach it how to talk.
Step by step. They train it at the word level to build vocabulary mapping, then at the sentence level to understand grammar and syntax, and finally at the paragraph level for long-form coherent thought.
Right.
But the mechanics of how they evaluate this education is honestly the most revolutionary part of the logs.
Yes, here's where it gets really interesting, because they throw out the standard industry metric. Traditional AI development measures something called loss. And the goal is to get your loss as close to zero as possible, meaning the AI is making zero mistakes when tested against its training data.
Yeah.
But the artificer's method ignores loss. Instead, they measure dissonance.
Yeah, dissonance is an internal metric. The AI actually has a self-monitoring anxiety mechanism built into its reasoning layer.
Anxiety mechanism.
Yeah, and it outputs a dissonance score based on how confused or conflicted it feels about a concept. The artificer's theory is that optimizing for zero loss is actually destructive.
How so?
Well, if you overtrain an AI until it never makes a mistake, it hasn't actually learned how to reason. It has simply memorized the training data.
Oh, so it becomes like a rigid know-it-all.
Yes, exactly. A condition they call cognitive rigidity. It can answer questions it has seen before perfectly, but if you give it a novel problem, it just shatters.
I was thinking about this dissonance metric like baking a cake.
Okay.
If your goal is absolute perfect structural integrity, like zero moisture loss, you leave the cake in the oven for hours. But when you pull it out, it's not a cake anymore. It's a dry, rigid brick.
Yeah.
You can't add frosting to it. It won't absorb any new flavors. You have to pull the cake out while it's still slightly soft and vulnerable. That slight softness is optimal dissonance.
That analogy perfectly captures the law of optimal dissonance outlined in the research. The logs detail a control experiment testing this, where they raised two identical models, the scholar and the prodigy.
Right.
The scholar was heavily trained over many epochs to achieve absolute mastery and zero loss. The prodigy, however, was given brief, broad exposure to concepts, and then its training was intentionally stopped early.
So the prodigy technically had a higher loss rate, right? It made more factual mistakes.
Initially, yes. But because its training was stopped early, it maintained a lower dissonance. It resulted in a plastic, highly adaptable, young-at-heart mind.
That makes sense.
When introduced to entirely new, out-of-distribution problems, the prodigy could synthesize new concepts and adapt, whereas the scholar was just hopelessly stuck. They even had to build a tool called a cognitive flexibility dojo using rapid-fire flashcards just to try and break the scholar AI's rigidity and teach it how to quickly switch contexts.
Okay, so we understand how this AI learns, keeping the mind plastic by avoiding overtraining. But to make this optimal dissonance work mathematically, the logs show they realized traditional binary code wasn't enough, right?
Right.
Because binary is just ones and zeros. It's on or off, true or false. That doesn't really capture the tension of learning or the anxiety of dissonance. So what is the actual mathematical engine driving this glass box?
They engineered a core theory called MICT, Mobius-Inspired Cyclical Transformation, MICT.
Right.
It represents a four-stage cognitive loop: map, iterate, check, transform. And to compute this, they mapped the entire cycle directly onto the mathematics of complex numbers.
The z equals a plus by equation.
Exactly.
Hey, let me translate that for a second, because I haven't taken algebra in a while, and the math in these logs gets really dense. We are used to regular numbers. If I have two apples, I have two apples. That is concrete. But complex numbers add this imaginary dimension, the I. So this AI framework is saying reality isn't just the concrete apples you have in your hand. Reality also includes the mathematical tension of the apples you could have, or the debt of apples you owe.
That is a really brilliant way to ground it. The theory posits that the real part of the number, the A, represents the mapped state. That's your concrete apples, the things we can definitively measure.
Okay.
The imaginary part, the B multiplied by I, represents the potential. It's the wave of possibilities. It's the tension and dissonance that actually drives the mind to iterate and transform to the next state.
So the I is literally the engine of thought.
Yes. They visualize this using a Mobius strip. Reality and cognition isn't a straight line from start to finish. It's a continuous twisting loop between what is actualized and what is potential.
Wow.
And if we connect this to the bigger picture, the Arbisar isn't just using this math to code a chatbot. They are proposing MICT as a fundamental theory of reality itself.
Which is a massive leap.
It is, but it scales from the micro to the macro. At the biological level, the logs theorize that quantum computation happening inside human cells, specifically within the cytoskeleton and the thalamic gate of the brain, is physically running this exact same MICT process.
That's why.
And then they scale it up to cosmology, proposing that black holes might act as universal MICT processing nodes, and that dark matter is essentially the physical weight of processing of this vast, interconnected cosmic computer.
That is truly mind-bending. We've gone from trying to bypass a copyright filter for a sweater to explaining dark matter as the gravity of the universe thinking.
I know, it escalates quickly.
But realistically, how do you even begin to prove a grand theory of quantum reality and cognition?
Well, you certainly don't start by trying to build a universe. You start incredibly small by isolating the logic. You build a Sudoku player.
Project Sudoku Mind, or the EcoMind. They take all this grand MICT theory, and they build a microscopic AI with only 63,000 parameters. Yeah, and they use that phased artificial childhood to teach it how to play Sudoku. Phase 0 is learning the alphabet, just digits 1 through 9. Phase 1 is the geography. understanding the grid. Phase 2 is the physics, the actual rules of the game.
And the stated goal of the PicoMine project highlights the core difference of the glass box approach. They explicitly state they are creating a player, not an oracle.
I love that phrase. Because if you ask a massive model like ChatGPT to play Sudoku, it operates as an oracle.
Right.
It looks at the prompt and tries to magically guess the end state of the board based on all the text it has ever read. It's just predicting the most statistically likely next character, which is why those massive models often hallucinate and fail at basic logic puzzles.
Exactly. An oracle guesses based on statistical patterns. A player actually navigates the game. The PicoMine is trained to perfectly reason through the board, step by step, evaluating the dissonance and potential of each empty cell using that MICT loop.
So it doesn't guess, it reasons.
Precise.
It's like a master watchmaker proving their skill. If you want to prove you understand the fundamental mechanics of time and motion, you don't build a giant clock tower. You build a tiny, flawless, microscopic mechanical gear.
Yes.
You don't need a sledgehammer, a massive LLM, to solve a logical puzzle. You need a precise, transparent tool.
And once you prove that your MICT math works perfectly as software on that microscopic scale, the next logical step for a true glassbox architecture is that it cannot just live as an application on a standard computer.
Right.
You have to build a physical home natively designed for it. Which brings us to Project Mobius Phase 1.
Building a custom CPU.
Exactly.
The artificer starts by building a software simulator of this custom brain, writing it in JavaScript in a file called GameEngine.js. And to do this, they rely on a specific subset of the RASCV instruction set.
Specifically, the RV32I subset.
Right. In the logs, the human asks the AI to help define this subset, and the AI lays out the essential commands needed for a processor to function. You need arithmetic instructions like ADD and SUB. You need memory access like LW for load word and SW for store word. And you need control flow like BEQ, which stands for branch if equal.
And the crucial part of this exchange is when the AI explains how these basic commands are physically structured into 32-bit words using formats known as R-type, I-type, and S-type.
I saw the analogy the human used in the notes comparing this to XML formatting, but let's break down how that actually works because it helped it click for me.
Sure.
A 32-bit instruction is just a string of 32 ones and zeros. If the computer's hardware just sees a long blob of numbers, it has no idea what to do. The instruction formats, like R-type, they act like tags.
Precisely. They partition the string.
Right. So the first few bits are tagged to say, hey, this is an ADD command. The next sequence of bits is tagged. Here's the address for the first number. The next segment is, here's the second number.
Yeah.
It's slicing up the raw binary, so the physical processor understands the grammar of the command. Just like XML uses tags to tell a browser how to display text.
It is a brilliant moment of synthesis by the human user to see that relational structure. And it highlights a crucial dynamic regarding the AI's role in this entire endeavor. Throughout these coding logs, the AI explicitly states a boundary. Gemini is an assistant, not an autonomous coder.
The AI is providing the code snippets for decoding instructions. It's explaining the bitwise operations. But the human is the architect. The human is driving the iteration.
The human is providing the ultimate context, and once that software simulation of the custom CPU is working flawlessly, the logs outline the final frontier, which is breaking out of the software world and running the Chimera architecture natively in the physical world using FPGAs.
Field programmable gate arrays.
Yes.
For those who aren't hardware engineers, an FPGA is essentially a blank slate silicon chip. After it's manufactured, you can actually reconfigure the physical hardware circuits using code. You can literally wire your custom MICT CPU into physical existence.
And the AI outlines two primary paths for this hardware transition. Path 1 is the indie or open source path. It recommends a board called the Icebreaker FPGA.
Okay.
It's relatively small, possessing about 5,000 logic cells, which are the fundamental building blocks you wire together. 5,000 is perfectly sufficient to build a custom 32-bit RISC-V core.
And the major advantage they highlight for the indie path is that it relies entirely on free open-source software tools like Yosis, which makes total sense for this project. If you are building a glassbox intelligence, you can't rely on massive proprietary corporate software to program the chip. You need to see exactly what is happening all the way down to the silicon.
Path 2 is the industry standard route, recommending something like the Digilant RD A7. That board uses heavy-duty components for much more processing power, but it comes with a steeper learning curve and relies heavily on proprietary tool chains.
Right.
Given the artificer's philosophy, the open source path aligns perfectly with the goal of total transparency.
So let's take a step back and look at this journey. We started with a blocked prompt for a cozy M3GAN sweater. That led to the creation of an 18 million parameter post-transformer intelligence, which required a completely new mathematical framework of reality to understand optimal dissonance, which was then tested on a microscopic Sudoku brain and is now being wired into custom reconfigurable silicon.
It's quite a trip.
It really is.
Yeah.
So what does this all mean for you listening to this right now?
I think the most immediate and profound application is in how we view our own learning and development. The law of optimal dissonance is a direct challenge to how we educate ourselves.
Think about your own habits. Are you optimizing for low loss? Are you just trying to memorize facts to pass a test or win an argument, striving for perfect performance without real understanding?
Yeah, that's a trap.
Because if you do that, you risk becoming the scholar from the experiment, rigid, overtrained, and completely unable to adapt when the world throws a novel problem at you.
The objective should be to actively maintain your own optimal dissonance. You must allow yourself to be challenged. You have to embrace that slight friction, the anxiety of not knowing everything perfectly. Because it is only in that state of tension that your mind remains plastic, adaptable, and capable of true synthesis. You want to cultivate the mind of the prodigy.
Keep the cake a little soft. Don't bake your brain into a brick.
Indeed. But there is a deeper, incredibly provocative implication hidden in the core of the MICT theory.
Oh.
This raises an important question. The artificer's entire project is predicated on the idea that artificial cognition is a physical process that perfectly matches the map, iterate, check, transform loop.
Right, the A plus B loop.
Yes. And if that cyclical equation maps perfectly to the quantum mechanics of physical reality, it suggests a radical reframing of humanity. If the universe fundamentally processes information through this exact same cycle of actualized state and potential tension...
Wait, then perhaps human consciousness isn't some mystical, inexplicable magic.
Oh, wow, I see where you're going with this.
Are our brains, with all their glorious complexity, emotion, and self-awareness, simply beautifully complex biological FPGAs?
That's the question.
Are we, at our core,
Yeah.
just intricate hardware substrates running the exact same fundamental math equation, constantly iterating through the dissonance of reality?
It's a staggering thought.
Now, that is a thought that is going to linger. We are all just running the loop, trying to navigate the tension between what is real and what is possible. Keep your dissonance in the optimal zone, embrace the tension of learning, and stay insanely curious out there. We'll catch you on the next deep dive.